Hi Math 111. This is the second video talking about section 1.5 discussing circles. And in this video we're going to talk about a couple special kinds of equations of circles and do a couple examples. So recall that we have the definition or the equation of a circle, right? A special kind of an equation right here, right? X minus h squared plus y minus k squared equals r squared. And remember that with this equation for a circle, we know that the center is the ordered pair hk and the radius is r. Again, remember it's not r squared that's the radius, it's just r. Okay, so I'd like you to consider a special sort of modification of this, right? So let's consider something. So what would the equation look like if our center was at the origin? Like if we had a circle whose center was at the origin. So let's consider if center at origin. Okay, well, if the center is at the origin, then that means that the center, the ordered pair for the center is 0, 0, right? And what would the equation look like if we did in fact have that as our center? Well, we would have, let's see, x minus 0 squared, oops, plus y minus 0 squared equals, well, I don't know what the radius is because I haven't assigned that to anything, so let's just leave that at r squared. Okay. So now notice x minus 0 is just x, and we square that, so that's just x squared. Plus the same thing here, y squared equals r squared. Okay, and this is another special kind of equation for us here. Let's just put a little box around this. Okay, this is a special equation because this is the equation of a circle that's centered at the origin, right? And of course you get to choose the radius still, right? We could choose whatever we like here to be the radius. For a specific kind of a circle centered at the origin, we can choose a special radius, right? And this is a really frequently used circle, especially in 112, but in other places as well in mathematics and geometry as well. So it's what's called the unit circle. Okay, it's called a unit circle because it's a circle whose radius is 1, and the word unit sometimes is synonymous with 1, right? So in this case, the unit circle is, it has its center at the origin. So its center is 0, 0. And the radius in this case is 1. Okay, and so let's see what the equation would look like. Well, we know that for any circle centered at the origin, right, we're of this form down here, right? Okay, so we know that we're going to be x squared plus y squared equals, and then I write r squared here, right, according to our form here. But I know that my radius is 1, so that's just 1 squared. 1 squared, but 1 squared is just 1, so we can just write a 1 right there. Okay, and this is another important equation of a circle for us. This one we use a lot, okay, especially in trig and things like that. Okay, so these are two equations of circles that are very, very good to keep in mind. We're going to be using those quite a bit throughout the rest of the term, I think, and then perhaps if you're continuing on to other classes, you may use those as well. So let's do an example of actually graphing a circle when we are given the equation of the circle. Okay, so let's start with an example. Let's say we'll graph, and the equation is going to be x plus 6 squared plus y minus 5 squared equals 9. Okay, so how would we go about graphing this thing? Notice it doesn't say we have to graph it on our calculator, right? So if it doesn't say we have to, then we don't have to, right? If we can think about graphing this thing by hand, I mean, it's just a circle, right? I mean, it's pretty easy to draw a circle. You just have to know where to put it and how big to make it. Okay, well, those two questions about where do we put it and how big do we make it are answered by knowing the center and the radius. So if we think about our equation of a circle for a second here, let me do it in a different color. All right, let me think about this for a second. It is x minus h squared plus y minus k squared equals r squared. Okay, that's, remember, the equation, the standard form for the equation of a circle centered at hk, radius of r, right? Okay, and then on the previous pages we made some modifications to that to center it at the origin and so forth, right? Okay, well, let's see if we can compare our equation to this standard form equation. It looks really similar, right? Except for there's maybe a little bit of a difference here, right? Where this plus is right here. Yeah, that's different than in our equation here. Yeah, and that could be causing us some trouble. But if we would really like this to say x minus a number, we could actually force it to be that way. Let's see what I mean by that. Let's choose a different color. So if I instead wrote this x plus 6 here as x minus a minus 6, notice those two things still say the same thing. X plus 6 is the same as x minus a minus 6. And why do we even bother doing that? The reason is so that these two forms look similar, right? It says x minus a number. Okay, so that can help us determine what h has to be, right? H in this case is going to have to be minus 6 because I've made the forms look exactly the same. X minus a number, and the number has to be negative 6. Okay, we don't have to do that with the rest of this, but let's just rewrite the rest of the equation so we have it here. This part already matches y minus a number, y minus 5, so k has to be 5, equals 9 I can write as 3 squared, and that'll help us see what r is going to be. Okay, so let's go ahead and write out what we in fact do have. So we know that for our circle, the center is what? Again, remember we go here and we see that h has to be negative 6 and k has to be 5. Okay, and our radius is 3. Okay, so to graph this thing, because that's what we were instructed to do, we were supposed to graph this thing, ooh, that's a nice line. Okay, ooh, that's not such a good line. Let's try that one again. That's better. So to graph this thing, I suggest first putting the center down, and then trying to figure out how to do this radius here. So let's start with the center. We go over to negative 6 and up 5. So let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Good. Okay, and I'll pick, how about red? So negative 6, 5. Put a nice dark dot right there. Maybe not so dark. There you go. Now that's the center, right? You can, if you want to, you can label that like with a little C or something if you want to, so you remember that that's the center. Now, to do the radius, what I suggest doing is counting 3 units away in any direction you like, and that'll get you to a point on the circle. But if you go 3 units away in the easiest directions to count, that's the best thing to do. So no, notice I could count 3 units to the right, 3 units to the left, 3 units up, and 3 units down, and I could put those 4 dots that result and then connect them smoothly with a circle. Okay, and that might be the easiest way to go about doing this. So let's go ahead and count 1, 2, 3 units down. So that puts me here at negative 6, 2. And my colors keep popping up. And then let's count 3 units to the right. 1, 2, 3. Let's see, 1, 2, 3 over here. And then we need to go up 3. 1, 2, 3. Okay, good. And now we can connect them smoothly with a circle. I'm going to try my best. Let's see how this goes. Circle. Yes, it's a little bit off on the sides, but you get the idea. Okay, so that's how we can graph a circle like this, right? Okay. If in fact you did want to try to graph this thing using your calculator, right? Remember that your calculator requires that you do equations in terms of y equals, right? And this thing is definitely not written in terms of y equals, okay? But we could make it written in terms of y equals. So let's see if we wanted to graph with our calculator. Okay, if we wanted to graph it with our calculator, what we would need to do is take this equation here, this one over here, write our line here. If we want to take this equation here, we want to solve for y. Okay, so let's see. If I was going to solve this equation for y, I noticed that y is sort of inside this squaring thing here, and then it's adjoined by addition here to some other thing involving x. So let's get this thing involving x away from the y stuff. Let's move all that x plus 6 squared to the other side. So when I do that, I get y minus 5 squared equals 9 minus x plus 6 squared, right? I'm going to solve, at least try to get all the y stuff on one side and all the x stuff on the other side. Good? Well, I see that if I have y minus 5 squared, right, then I need to try to undo this squaring action here, which means square rooting things, okay? So when I take the square root of both sides here, remember we could use a color to show that, right? When I take a square root of both sides here, okay, then I get plain old y minus 5 on the left. But what happens in that taking of the square root process? I end up getting two answers. I get a plus and I get a minus square root, right? I get two things, 9 minus x plus 6 squared, right? Okay, the reason for that plus minus again is because of the property of square roots, right? So we generate a plus answer and a minus answer. I don't quite have the y by itself, but I could get the y by itself by adding 5 to both sides, right? So again, I can show you that step if you like. So I'm going to add 5 to both sides. Okay, but I can't add that 5 like inside the radical or any of that kind of stuff, right? So, because it can't just jump in there. So it has to be sort of out front of the radical, just being added to the radical. So I get plus 5, or just 5, plus or minus the square root of 9 minus x plus 6 squared. Okay, and we're so close because notice that we have, in fact, a y equals equation. In fact, we have two of them, right? We have y equals 5 plus the square root of stuff and y equals 5 minus the square root of stuff. Okay, so at this point to graph with your calculator, you just need to enter these two equations. Into your calculator. Okay, these two equations meaning the 5 plus the square root and the 5 minus the square root. And when you do both of those, you will be able to graph this circle in your graphing calculator. And you might notice that something weird happens near the breaking point here. That's because of a pixel issue with your calculator. Okay, if you'd like to see more of an example like this, then you can watch the video on the Graphing Calculator Basics worksheet that we did from the very first week. Okay, so one last thing we can talk about for this section is that there's an alternative form for the equation of a circle, right? And so for right now we have the standard form, right? Right, the standard form, remember, is this hk thing, right? The x minus h squared plus y minus k squared equals r squared. Right, that's our standard form. Instead, there's an alternative, which is what is called the general form. Okay, and it looks a little bit different. The major difference is that there's no parentheses, and it's always an equation that equals 0. Okay, so this one looks like this. It looks like x squared plus y squared plus ax plus by plus c equals 0. Okay. So these are both equations of circles. One is the standard form for the equation of a circle, and the other is what's called the general form of the equation of a circle. Okay? A huge difference between the two is that in the standard form, there is a place to input information about the center and the radius. Right? So remember, the center is hk and the radius is r. In the general form, there's nowhere to input that information. Okay, these letters A, B, and C, they do not stand for the center and the radius or anything like that. They are coefficients, right? They are numbers in front of the variables and a constant. Okay, so this is why we don't normally use the general form, because there's nowhere for us to input information about the center and the radius, right? But we can move between these two forms. And let me just end this video by telling you how we move back and forth between the two forms, okay? So from the standard form, if we want to get to the general form, then all we have to do is FOIL out these parentheses and move over the r squared. Okay, so to move from this to standard form to the general form, we FOIL. Okay, and then make sure the equation equals 0. Okay. To go backwards, to go the other way from the general form to the standard form here, to go this way, okay, what we have to do is try to get the parentheses back. Okay, and remember that from powers like this, to go back to parentheses, we can complete the square. And we'll talk about that in another video.